as promised, the last two examples of graphing these piecewise functions looks very similar to the last one we just did. It's in three pieces. So we're going to have the x and the y axis drawn in. And for the first piece, for all values less than or equal to -3, we are going to be part of this line. And we'll graph this piece in blue. I always like to start off with blue. So once again, I'm going to start off with the -3 and then go to the left. If x were -3, 3 times -3 is -9 plus 12, we would be at 3. Okay? And a closed circle, because it's less than or equal to, it includes -3, so that is the point -3, 3. And since the slope is 3, I know this line's going to look like this with that positive slope. We do have an x-intercept to find, so let's find that. How do we find the x-intercept? We plug 0 in for y. So 0 equals -3x plus 12. We move the 12 by subtracting it. And then divide by -3. So sorry, that would be positive 3x. I just realized my mistake. We divide by positive 3 for -4, 0. There is our y-intercept. Now that's the first part of the graph. The second part of the graph, we are going to graph y is equal to the absolute value of x. Okay, and -3 isn't included, but that's right there. The absolute value of -3 is 3. The absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. So we have a straight line coming down like this. Then when we plug in 1 and 2, now when we plug in 3, we got 3, but that once again is going to be an open circle because it doesn't include 3. So that's what that middle piece looks like. It's a V shape. Remember we talked about in the last video with the piecewise where that absolute value function is a V shape. And we're going to graph the last one, -3x plus 12. In green, plug 3 in for this x. We have -9 plus 12 is 3, so we are actually right here. That's included on the green part of the graph. And the slope is -3. So it's going to look a lot like that. We do have an x-intercept to label. We forgot the y and an x-intercept there. The x-intercept out here again is found by plugging 0 in for y. Subtracting 12, we have -12 is equal to -3x. When we divide by -3, we have 4. So once again, this is the point 3, 3. And that's what the graph looks like. We will talk about domain and range in class tomorrow. So, last but not least of the graphs, just two pieces this time. First one, we'll graph y equals x squared minus 4 and just plug in some values. See if we can get some sort of shape for this. If we plug 3 in for x, we've got 9, because 3 squared is 9. 9 minus 4 is 5, so that's where it starts. So over here at 3, we're up at 5. And again, that's going to be an open circle. And then we'll move to the left. For 2, we have 4 minus 4 is 0. For 1, 1 minus 4 is -3. Should be about down here. And for 0, 0 minus 4 is 4. When we plug in -1, -1 squared is 1, minus 4 is -3. that's when we get that rebound. So once again, we have this graph right here, and this point is the point 2, 0. So we'll label that. Here's the point 0, negative 4, letting x be 0. And this graph, this point, because we'd be at 1, negative 1, negative 3, and negative 2, and 0. Okay? Now, the second part we'll graph in red, only a two-color problem this time. And that's the line y equals 2/3 x minus 5. And once again, we're going to start with 3. This is going to be a closed circle this time. 2/3 times 3 is 6/3 divided by, so 6 over 3 is 2. 2 minus 5 is negative 3. So at 3, we're down here at negative 3. So we're at positive 3, negative 3, and our slope is 2/3. Slope is positive 2/3. So we've got one x-intercept to find by plugging 0 in for y, moving the 5, so we have 5 equals 2/3 x. Again, dividing by 2/3 is the same thing as multiplying by 3/2, so we have 15/2, 0. And that is the graph of that function. We are done graphing. The next video deals with writing piecewise functions for graphs that are given.